Hello, Math Study students. Let's take a look at our 5.3 notes, line of regression. The regression line for y on x, where y is the dependent variable, is a more accurate version of the line of best fit than when we just do best fit by eye. In other words, when we just try to find that mean point and then draw the line of best fit by hand. That's very inaccurate. So we can actually calculate a more accurate regression line. The regression line is drawn through a set of points such that, now here's the arithmetic behind why it works, such that the sum of the squares of the distance of each point from a line is a minimum. So there's another name for this regression line. It's also sometimes called the regression line for y on x. It's also known as the least squares regression line. So you can imagine that there's a lot of arithmetic that goes into finding the sum of the squares of the distance of each point and showing that each of those distances is a is a minimum. So for this course, we will let the calculator do that, or all that arithmetic. We're just going to use that line of regression to possibly sometimes make a prediction. Now, the line of regression for y on x is going to be helpful for us when there is a strong or when there is a moderate correlation. The regression line can then be used for y, or the regression line for y on x can then be used to predict values of y for values of x within the given range of data. So in other words, we can use this line. The calculator can make a very accurate line for us that best fits our data, and then we can use that data to predict other values. Okay, so in other words, we have been drawing lines of best fit by eye. We've just kind of been hand drawing them, but now we can let the calculator calculate a more accurate line. So let's take a look at a couple examples. And again, you won't be able to do these examples until you get in class and use a calculator, but I've listed for you the steps that you'll follow on your calculator. So this first example says 10 students train walk for a charity walk. The table shows the average number of hours per week that each member trains and the time taken to complete the walk. So here's our training time, and here's time to complete the walk. Now it's important to look at your data and figure out which one is your dependent variable and which is your independent. So we need to determine, does training time depend on time to complete walk? Or do you think it's the other way around? The time that you can actually complete the charity walk depends on how much time you spent in training. That second sounds a little more reasonable. So we're going to go ahead and label the training time as our x values and the time to complete the walk as your y values. So now that you have that identified, you'll follow the steps over here to put your data into a spreadsheet. Make sure you label those, the headings on each of those columns. Then you'll follow these steps, and the calculator, it won't actually give you the equation, but it'll tell you what M is and it will tell you what B is. And then you can go ahead and write that equation. This calculation will also give you R, the correlation coefficient. Remember, we're only interested in this regression line if the correlation is strong or moderate. So the calculator, if you punch this into the calculator and get the statistics from it, the calculator will tell us that R is equal to negative 0.767. So that is a pretty strong, it's not very strong, but it's a pretty strong, and it happens to be, we'll just go ahead and list, it's a strong negative correlation. So since it has a strong correlation, then we can use the regression line as a predictor. So what you'll do is look on your calculator, and the calculator will tell you what M is, your slope, and also B, the y-intercept. So then we'll write that equation. The equation of the line, I'm going to write it down here for letter B. The equation of the line is y equals negative 0.147x plus 17. That's the equation of the line that best fits the data, and so now we can use that equation for letter C. Letter C says, using your equation, estimate how many minutes it will take a student who trains for 18 hours to complete the charity walk. So if you look up here, it looks like our data ranges from the smallest, our x values, range. The smallest value looks like it's 3, and the biggest value is 25. So 18 definitely falls in, I'm using the word range. I know these are x values, but it does fall in the range of those x values. So that means we can use the line as a predictor. So we will say for letter C, to find how many hours it takes a person to walk in the charity walk if they train for 18 hours, we'll take negative 0.147 times 18 plus 17. Go ahead and do that calculation on your calculator, and then we get 14.4 minutes to 3 significant digits. That's how long it would take a person who trains for 18 hours to walk the charity walk. So let's take a look at one more example. This one says the table shows the number of mice for sale at a pet shop at the end of certain weeks. So we have labeled for us our independent and dependent variables. The independent variables are the number of weeks, and then the dependent variable is the number of mice sold. Ugh, why anyone would want to buy one, I don't know. But anyway, let's take a look at letter A. Letter A says find the correlation coefficient. So if you follow the steps up here in your notes, the calculator will find that for us. That correlation coefficient turns out to be, R is 0.990. So that's a very strong positive correlation. You can write down positive if you want to, but it's a strong correlation. So since there's a strong correlation, then the regression line can be used for predictions. So let's go ahead and find that regression line. The calculator will give you M and B. And so you'll write down the equation. It turns out to be y equals 4.63x plus 30.9. So then letter C says use your regression line to predict the number of mice for sale after 10 weeks. Well, 10 weeks definitely falls in our range, meaning smallest to largest values of the x values. So we can use the line to predict how many mice were sold after 10 weeks. So that would be 4.63 times 10 plus 30.9, which turns out to be 77.2. Well, we're talking about mice, so you're not gonna hopefully sell 2/10 of a mouse. So let's go ahead and round that and say about 77 mice is what we can predict would be sold after 10 weeks. And then letter D says, can you accurately predict the number of mice after 20 weeks? And the answer to that is no. And the reason why is because 20 weeks is way outside of this range. We were only looking at weeks that range from 3 to 13. So we cannot use the line. We can only use the line to predict within the data we're given. So we'd have to say no because 20 is outside of and I'm using the word range, but I don't mean that in terms of y values, but the range of, I'll say, x values or independent values. Okay, and then I wanted to make sure to include this in your notes. This is a formula for actually calculating the line of regression. We won't ever need to use this calculation for homework or tests or quizzes or even your papers in May. And during examinations, you'll be expected to use your graphing calculator to find the equation of the regression line. But you might want to use a regression line depending on what your IA is looking for, what kind of data. If you have that strong or moderate linear relationship between the data, then you might use this equation or might use this regression line to make a prediction about your data. So if you use that regression line, you would actually have to calculate it, and here is the formula for that. So when the time comes, if you need that equation, I just want you to know that it is in your notes, and I can certainly help you with that if you choose to use it in your IA. All right, so here are your homework problems. They will be posted in Google Classroom, so you'll be working on those in class. And if you have any questions, be sure and ask.